All right, y'all. Here is your last video of the week. Thank you for participating, tuning in, and watching. Right now, I'm going to talk a little about predation, which is basically just the relationship between a predator, like a wolf, and its prey, like the rabbit. What you'll see usually in predation studies are these graphs. And the graph doesn't represent over here how successful the organism is, or like, I don't want you to think that here the rabbits are beating the wolves because there's so many rabbits compared to the wolves. The graph represents the population size relative to the other over time. And what you see here is when we start about time equals 5, the wolf population pretty low. Not eating a lot of rabbits, so the rabbit population skyrockets. Then when the rabbit population gets high, there's a lot more food for those wolves. The wolves then increase their population size. They're able to mate, stay alive longer, have more babies. Okay, so again, it doesn't matter that the rabbits are up here and the wolves are down here. What matters is how they peak and at what time they peak. So basically, at this point, there's a lot of wolves. What does that do to the rabbits? Kills them because they eat the rabbits. The rabbits come down. Now the wolves are down because there's not a lot of food. So we see this predator-prey cycling based on the availability of the food for the rabbits, and then the growth of the wolf population when there is a lot of food, the decline of the wolf population when their food ain't so plentiful. So, a couple things I want you to know about that. I wrote them down here for you. Number one, the prey populations always peak before the predator populations. Okay, demonstrated that on the graph. Number two, the peaks of predators and prey alternate with one another. They can't both be high. Okay, does that make sense to y'all? They can't both be high, because if here the wolf population was high at the same time the bunny population was high, the bunnies get all eaten. Does that make sense? So the bunny population peaks when they're not getting eaten, when the wolf population's low. The wolf population peaks right after the bunny population peaks. I think y'all understand that, but just summarizing it over here on this piece of paper. Now here's my favorite part. Predation is necessary for ecosystems. It keeps them functioning. And I don't know about you, but I kind of feel sorry for those little rabbits.
Me too.
Oh, Jude says he does too. His favorite animal is a bunny. But we sometimes think that predation is mean or fierce or excessive or needs to be controlled, because we associate killing with violence. We associate killing with negativity, right? But then we got to remember, if we get rid of the wolves, so if there are no wolves, what are the rabbits going to do? They're going to skyrocket. And if they skyrocket, then what's going to happen to the ecosystem? Something called overgrazing. What does that mean? These predators eat some herbivores. Herbivores eat producers. If the predators aren't there to keep the herbivore population in check, too many herbivores, too much eating of the producers start to die. And this is your basis of the ecosystem stability, maintaining producers. Because if your producers die, whole thing collapses. Remember, producers are on the bottom, the foundation of the pyramid. All right, next topic, real quick. This is kind of easy, but some of you had questions on it. Symbiosis just means there's an interaction between two living organisms, and one of three things can happen. Both organisms can benefit from that interaction. Clownfish anemone, classic example. Clownfish gets a place to live, protection from its predators. Anemone gets food scraps from the clownfish. Tick on a dog, parasite, the host is harmed. Classic example. You wouldn't call coronavirus a parasite, although it does cause disease because coronavirus is not a living thing. But any sort of parasite is going to live on or in another living thing and then cause it harm, disease. It usually doesn't kill its host, because if it kills its host, then it's out of a home. All right. Finally, commensalism. Really hard to find examples of this, boys and girls. Commensalism, example here is like a tree frog that hides in the plant leaves, but the plant doesn't benefit, it's not harmed, it doesn't care. I don't like this example though, because how do we know the plant doesn't care? Maybe the tree frog takes a poop and that fertilizes the soil, and so it's a benefit. Then I'd call it mutualism. So I don't know. I mean, you're going to see questions on your quiz tomorrow where you have to basically say, is it commensalism? Is it parasitism? Is it mutualism? And at that point, you just go with the definitions here. But I don't like much of these examples. I'm going to show you another one over here on my computer. Okay. I like these pictures. They're nice and clear. There's the tree frogs over there. Again, maybe that plant doesn't like the tree frogs. Maybe the tree frogs cause injury to the leaves. I don't know. Again, cattle, egrets, I guess they're birds. They eat insects stirred up by the cattle when they're grazing. How do you know the cattle don't like that? Finally, this one I think is good, commensalism. Hold on one second. Jude, turn that off. This is a good one. Golden jackals, which are right here, they look like a dog. Once they have been expelled from their pack, will trail a tiger to feed on the remains of its kills. I think that's a good example of commensalism, because obviously the tiger's not going to care. All right, children, that's it for today. Email me with questions. 20-point quiz tomorrow. Here's my little workstation. And take care.